Okay. Well, good morning, everyone. My name is Maddie. As Tim mentioned, I am the Research and Community Science intern, and it has been an absolute blast working here this summer. I recently graduated from UW-Madison this spring with my Bachelor of Science in Conservation Biology and Environmental Studies. And I'm super excited today to be chatting about eutrophication. um, I've always had an interest in aquatic ecosystems and water quality, so I'm happy I got the opportunity to talk with you guys about this today. Okay, so before getting into the the weediness of things, I wanted to first talk about trophic states. Um, okay, I want to talk about trophic states. Which essentially describes the quantity of nutrients in a water body measured by the trophic state index, which is the total mass of biological matter in an ecosystem. Trophic states basically tell you how nutrient rich or poor a water body is. This isn't necessarily interchangeable with water quality, but is often a very good indicator of water quality. There's four states. The first is oligotrophic, oligo meaning few, so few nutrient. And these water bodies are low in nutrients. Because of that, they tend to be very clear and also tend to be very cold. So you're going to see these water bodies um, often in cooler areas further north. And because they are so cold, they're often very oxygen rich. Colder water holds more dissolved oxygen than warmer water does. So the fish in these water bodies really thrive under these high oxygen conditions, um, high oxygen and low nutrient conditions. Then you get into mesotrophic water bodies, which, as the name suggests, are kind of in the middle. They have moderate nutrient levels and, as a result, moderate algae, algal mass. In these systems, you sometimes see algal blooms late in the summer, but typically you're sitting right in the middle. And then getting into eutrophic and hypereutrophic systems, um, these systems are going to have very high levels of nutrients, which, as I'll get into, nutrients aren't a bad thing, but when they go unchecked, they certainly have ecosystem-wide impacts. But eutrophic and hypereutrophic systems have very high levels of nutrients, which lends itself to very high biological productivity. Phytoplankton require nutrients and sunlight to thrive. And so sunlight is a constant factor for the most part. So when you have this influx of nutrients, they're just going to go crazy. And so you have a lot of biological productivity in these water bodies. And as I'll discuss, this can definitely lead to poor water quality. Um, but again, uh, trophic states aren't necessarily interchangeable with water quality, but often good indicators. So, what is eutrophication? Eutrophication, by definition, describes the excessive richness of nutrients in a water body. As I mentioned, algae require nutrients and sunlight to grow. These nutrients being mainly nitrogen and phosphorus. Nitrogen is generally more abundant in the environment than phosphorus is. So, of course, there are exceptions, but typically phosphorus is our nutrient of interest and is really going to be the major control on algae growth. Um, so nutrients, again, are a good thing. Um, they Phytoplankton are photosynthesizers, which means they are producing oxygen, which is great. And they also are form the base of the food chain. And so they provide food for a lot of organisms. But the problem arises when this algae growth goes unchecked. So when you have too many nutrients in a water body, you start to see the formation of algal blooms, which are essentially these mats of algae that overcrowd the water body, which is problematic for two reasons. The first being it blocks sunlight from reaching further down the water column. So some of those other photosynthesizers, those other aquatic plants, are unable to obtain the sunlight they need to grow and to produce oxygen. But the second issue with this is when the algae begins to decay and decompose. And during this process, the algae consumes oxygen, takes oxygen out of the water body, um, and in the most severe cases, leaves these waters in conditions of very low oxygen or even no oxygen. As a result, the life in the water body cannot survive. The fish suffocates due to the lack of oxygen. And again, in the most severe cases, you see these massive die-offs and fish kills, and it's not pretty. um, so this is what an algal bloom looks like. I'm sure you've seen it before. I know I definitely have, in a lot of lakes in Wisconsin in the summer. And as you can see, they are just all consuming. They really cover very large portions of a lake or water body. And as you can kind of imagine, there's not much sunlight getting past that thick green barrier. Um, so again, in the most severe cases, they are definitely problematic. Eutrophication is a natural process. It's something that naturally occurs over centuries. Nitrogen and phosphorus are both naturally occurring elements, so it is bound to happen. But what we're seeing today is known as cultural eutrophication, or this acceleration of the process due to human activity. This is primarily a result of three things. The first and maybe most important being increased nutrient inputs. Like mentioned, these are naturally occurring elements, but large scale agriculture has changed the game. And now we have fertilizers that contain a lot of nitrogen and phosphorus. And just in much larger quantities than these systems are used to having. So these man-made fertilizers are introducing a lot more nutrients into the ecosystem than ever before. And with this, it's important to note that as a result of climate change, we are experiencing increased runoff. So the fertilizer that is on the fields is being washed away by these intense rainstorms and intense precipitation. I mean, as we saw last weekend with all the flooding, Wisconsin definitely has to worry about precipitation increasing in frequency and intensity under climate change. So there's more nutrients on the landscape. These are being washed into water bodies more readily. And another factor further compounding everything is warming water temperatures. I briefly mentioned that cooler water holds more dissolved oxygen than warmer water does. So already these lakes, rivers are going to be at a disadvantage in terms of holding oxygen because they're warming and they lose their ability to do so to hold dissolved oxygen. But beyond this, warming water temperatures can accelerate the release of nutrients from sediments within the lake. So even if you were to magically snap your fingers and stop all the runoff and all of the external inputs, you have sediment within the lake that is releasing phosphorus. Um, and so eutrophication is going to continue, and the sediments are releasing phosphorus more readily under warmer water temps. So it's it's a messy situation, but mostly our fault. So one of my favorite examples of eutrophication on a very large scale is looking at the Gulf of Mexico dead zone, which is an area in the Gulf of very little to no oxygen. You're often going to see these massive fish kills, all these dead fish washing up on the shores of Texas as a result. But to really understand why this dead zone forms, it's important to know the nature of the Mississippi watershed. So the Mississippi River Basin is the fourth largest watershed in the world. A watershed is an area of land that channels rainfall and snowmelt to streams and rivers, which eventually flow to an outflow point. In this case, that outflow point is the Gulf. But the Mississippi watershed drains 41% of the country's water, which is incredible. But because of this, all of the fertilizer that we put on our farms in Wisconsin is eventually being washed into the Mississippi, which eventually flows into the Gulf. And so, as you can imagine, with 41% of the country's water going to this one outflow point, there is just an incredible input of nutrients coming into this area. And as a result, the algae are having the time of their lives. You're going to see these algal blooms that I mentioned. And then once those algae start to decompose, they are taking oxygen out of the water column, leaving us with these very low oxygen or no oxygen environments. The size of the dead zone varies year to year or summer to summer, but is thousands of square miles. The largest recorded was in 2017, and that one was 8,700 square miles, or roughly the size of New Jersey. So again, this is looking at eutrophication on a very large scale, but I think it's a really great example of how it operates. This is kind of a gross picture, but it's an example of the fish kills that occur as a result of the dead zone. So again, this is what you may see washing up on the shores of Texas or some of those other states bordering the Gulf. Massive, massive die-offs and loss of biomass in these ecosystems. So, any questions about anything I've talked about up to this point?
So, Maddy, the fish are dying because of the low oxygen, right?
Correct. Yeah.
Does it affect all fish, like the crawfish and the shrimp?
That's a good question. It certainly can. I think much of what I've learned about and read have focused on those larger bodied fish. That's a good question.
I just know that part of the
answer.
That part of the area is famous for it.
Yeah.
Oh, Forrest Gump went there. And
Yeah,
it's okay to not know it all.
yeah, I'm certainly not an expert. I think it primarily affects those larger bodied fish. Um, I don't know much about
Okay,
fish anatomy,
that's
but
fine.
having gills, I think probably.
I think the species of fish that varies how much oxygen they need too. So there's a wide range there.
Right. Some can really thrive under low oxygen conditions, but many cannot. That's a good question. I'm sorry I couldn't give you a better answer. Okay, so now I want to shift gears a little bit and discuss the health impacts of eutrophication. And I want to do this under the model of One Health. One Health is an interdisciplinary approach that recognizes that human health is very closely related to the health of animals and to our environment. And I really love this model because I think it is a great reminder that we are a product of our environment and we are as much of a part of these ecosystems as fish are. I think it's a really great way to frame health. So, the biggest health implication of eutrophication is from harmful algal blooms. Harmful algal blooms occur when bacteria in algae begin to produce toxins that affect human and wildlife health. There's a few different types of bacteria that produce toxins, but in freshwater, the primary one is cyanobacteria or blue-green algae. Symptoms can arise from ingestion of water or just contact, swimming, that kind of thing, and include skin irritation, muscle and joint pain, gastrointestinal symptoms like nausea, diarrhea, abdominal pain, that kind of thing. But these cyanobacteria thrive in this warm, nutrient-rich water, and a major consequence, thinking back to this cultural eutrophication, is cyanobacteria dominance. We're increasing the nutrient load into these systems, and due to rise in temperature, the waters are warming, and so these cyanobacteria are living their best life. They are just thriving under these conditions that we've created. And as you can imagine, these harmful algal blooms are increasing in frequency as runoff is increasing, as temps are warming. The Wisconsin DNR in 2024 received about 200 reports of blooms and 34 reports of bloom-related illnesses, which in the grand scheme of things doesn't seem like a whole lot, but it's definitely significant. And it was an increase from the year prior. And I'm sure we'll see higher numbers this summer because they are certainly becoming more frequent. An interesting example is Lake Superior. Lake Superior is typically a very cold lake, which, if you recall, tend to be oligotrophic systems or systems with very few nutrients. But Lake Superior is one of the fastest warming lakes on the planet. With this, you are seeing a loss of ice cover, but also a shortened growing season for ice, which lends itself to a longer growing season for phytoplankton. So the blooms are typically pretty short-lived, but they are increasing in frequency. And again, seeing more of these blooms is an example of how climate change is manifesting itself in our state. Okay, So getting into some impacts on wildlife, obviously mentioned the oxygen depletion, which is going to have a lot of effects, but one of those being a loss of general biodiversity. When you have these massive kills, you're removing a lot of species from the system. Also, on the note of biodiversity, you have zooplankton, which are one of the main consumers of phytoplankton, but you have zooplankton that are more sensitive to increases in nutrients, and prefer certain algae that are outcompeted by this dominant blue-green algae. And so likely you're going to see fewer zooplankton species, and that cascades up the food chain, which brings me to food web disruption. Again, you have these fish kills, and so you are losing a major food source for some of these larger predators, these tertiary consumers, which is going to increase competition further up in the food chain. So it's really crazy how fast these changes happen. And of course, habitat degradation is a major impact. Decreased water quality, low oxygen, these community-wide losses. There's a lot of effects that create lower quality habitat. So again, cyanobacteria affect us all, and it's important to consider the interactions between these domains. Cyanobacteria decrease the water quality in a system, which really impacts environmental health, affecting these species that live in those areas, affecting, again, community composition, but also affecting humans. Something I learned when preparing this presentation was that blue-green algae are not regulated in drinking water, and so they may end up in our drinking water. So even if you're not swimming in the blooms, you're not exempt necessarily from these effects. And another interesting connection to consider is the one between animals and humans. Algae accumulates in the food chain, and through a process known as bioaccumulation, the toxicity of a compound will increase as it moves up the food chain. This is true for heavy metals. I'm sure you've heard of mercury contamination. That's a really great example of bioaccumulation in food webs. But same for cyanobacteria. It's going to increase in toxicity up through the food chain. So if we consume a fish that has consumed blue-green algae, we are at risk of getting these nasty gastrointestinal symptoms. So we're all connected. It affects everyone. Just important to remember. Okay, I don't want to leave us on a completely depressing note, so I had to include a what can we do slide. A lot of the solution relies on large-scale agricultural changes, which isn't necessarily the most plausible in all situations. But shifting away from phosphorus-filled fertilizers is huge, even if it's just on your own lawn. Shifting to a different fertilizer to reduce the nutrient inputs into aquatic systems is huge. But beyond that, you can choose phosphate-free detergents, dish soaps, other cleaners, things like that. Maintaining wetlands is an important one. Wetlands and other riparian vegetation are fantastic natural buffers and natural filtration systems, and they really weed out a lot of those nutrients coming in. And so it's important to maintain the health of these systems. And you don't have to think as large scale as maintaining a wetland. Obviously, that's a big undertaking for an individual, but even thinking about creating a rain garden in your community or in your yard, or purchasing a rain barrel, anything that can limit runoff into these systems. And interesting note about wetlands that I wanted to include. If you are more inclined to the political action side of things, the Environmental Defense Fund has quite a few ongoing campaigns, but one of them right now is the Show Your Support for Our Nation's Wetlands campaign. So they give you the resources to contact your congresspeople about maintaining wetlands. So that's more up your alley. Certainly a great actionable thing you can do. But one of the best things you can do is to just stay informed. You know, if you see a bloom on a lake, you may contact the DNR. The monitoring capacity for blooms, unfortunately, is very, very limited. So any help from the community is great. But yeah, just contributing to the wealth of knowledge that we have about eutrophication, reading up on eutrophication events. The EWG is another great site that provides great articles and other resources that you can access to just learn more about lots of environmental things. But they do have a specific place on their website for toxic algae, where they submit articles and maybe companies you can avoid, like shampoo, detergent companies that you should avoid. So yeah, just staying in the know is good. That is all I have. If you have any questions, I'm happy to entertain them at this point.